Okay, guys, we've got plotting linear graphs here, and we've got a rule, and again, your output is y. Whatever the value of y is determined by whatever this rule is. Okay, so we'll do it a couple of times, and hopefully you get the idea of this. So x is your independent, which is your input. Okay, whatever you put into x is going to then determine what y becomes, right? So think of what we did with substituting variables in linear equations. If you make x -2, okay, so in this case, I'm going to write it above here. So if x is equal to -2, which is this value that we're focusing on, then y is equal to 3 times -2 plus 2. Okay, so here we have a rule. We're saying that whatever x is, we're going to multiply it by 3, and then we're going to add 2 after that. So we've done that. We've got 3 times -2, which is -6. Then we're going to add 2 after that, which gives you -4. So y is equal to -4 when x is -2. Okay, so let's apply this to a couple others and work it out with 1 or -1. So if x is equal to -1, y is going to be equal to 3 times -1 plus 2. So we have -3, so 3 times -1 is just -3, plus 2 is going to give us -1. So -1 goes here. If x is then 0, if x equals 0, then y is equal to 3 times 0 plus 2. And then obviously anything multiplied by 0 is 0, so we've got 0 plus 2, y is equal to 2. Okay, now remember, if we look back on the linear patterns, there was a pattern going across, and we can see that going from here to here, our x values are always increasing by 1. Okay, +1, +1. And I want you to have a look at this because that is always going to be the case with x. So let's just clear some space here. So we're going to add 1 every single time with x, but the real pattern is what happens to the y value. So going from -4 to -1 and going from -1 to 2, we're actually adding 3 every single time. So if we go and follow that pattern, then 2 plus 3 should be 5. And then we follow the pattern again, then 5 plus 3 should be 8. And we can test that. If x is equal to 2, then y is equal to 3 times 2 plus 2. Okay, so we're just substituting the value for x into the rule. And we can see that 3 times 2 is 6, plus 2 is equal to 8. Okay, so there's a couple of ways that you can actually check things and to make sure that you get it right. So we're going to plot this rule. So y is equal to 3x plus 2. There's our linear graph rule there. And I'm going to plot those points that we have in the table onto the graph on the left. So when x equals -2, y equals -4. So -2 and -4 is over here. -1 and -1, well, that's over there. And then 0 and 2 is over here. 1 and 5, that's over here. And we've run out of space, so 2 and 8 should be somewhere up here. Yep, so we can get our ruler, and the moment that your line or your coordinates are not straight, then that is already going to indicate that something hasn't gone quite right with your calculations. So let's say this point was over here, so we had a bit of a jagged part, then you would need to check your calculations to see what went wrong. Okay, so let's move on to the other rule that is just below another table, just to put things into practice. And in this case, we have y is equal to 4x minus 3. So y is equal to 4x minus 3. That's the rule. And whatever you substituted into x, you're going to multiply it by 4. Then after you've done that multiplication, we're going to take away 3. Okay, so let's put this in. So if x is equal to minus 2, then we have y is equal to 4 times minus 2 minus 3. 4 times minus 2 is minus 12. Minus 3 gives us minus 15. Okay. If x is minus 1, then we have y is equal to 4 times minus 1 minus 3. And 4 times minus 1 is minus 4, minus 3 is minus 7. If we substitute x for 0, then y is equal to 4 times 0 minus 3. And 4 times 0 is just 0. Take away 3 is just minus 3. If we have x is equal to 1, then y is equal to 4 times 1 minus 3. And 4 times 1 is just 4, minus 3 is 1. Okay. And then lastly, if we have x is equal to 2, then y is equal to 4 times 2 minus 3, which is 8 minus 3 and equals 5. Alright, so let's plot this, and I have a feeling like I've run out of space, but that's okay. So let's go backwards with 2 and 5. So x is 2, y is 5. We're going to put that there. When x is 1, y is 1. So we're going to put that there. When x is 0, y is negative 3. And then obviously we've run out of space, but we're gonna negative 1 and minus 7. Minus 7 is probably there, okay? Making it just off the chart, and we don't have room for minus 2 and minus 15. So I'm gonna jot these points together. There's our line. There's our straight line there, and there you go, guys. We've just plotted 2 linear graphs, looking at the rule and substituting the values of x into the rule to determine what the y value is. We can see that the pattern here, going from minus 15 to minus 7, we are not right here. So this is a very good, very good example to see. Look, the pattern, because we've gone backwards. Let's do this, okay? So between 1 and 5, we're adding 4. We're going to add 4 again from minus 3 to 1, and then we're going to add 4 again from minus 7 to minus 3. So that all holds true. But in my calculations, the very first time, I've done it wrong with negative 2. So let's check this again and see what I did incorrectly. So if x is minus 2, then y is equal to 4 times minus 2 minus 3. And so 4 times minus 2 is minus 8, minus 3 is minus 11. And that's where I went wrong. Okay, and so looking at this, we're adding 4. That makes, I'm happier with that. It makes more sense. So I'm happy to present, everyone makes mistakes here, but it's a perfect way to demonstrate how you can actually check if you've done something incorrectly and not just assume that what you did at the very beginning is correct. Okay, so if you have any questions, let me know. Otherwise, see you in the next one.